Yay, we're going backward. Now, which trig function is sine's reciprocal? Which trig function is sine's reciprocal? Cosecant. And then we use the three letters CSC for cosecant. Now, if you're trying to find angles for the answer to sine theta or the answer to cosecant theta, do you remember what type of line I told you yesterday to draw if it's sine? Horizontal line. So for example, if I tell you that the sine of theta is equal to root 2 over 2, and then I ask you, what angles is this true for? What angles solve this equation? I actually need to be more specific than that. What angles over the interval and I'm going to do including 0 degrees to 360 degrees, but not include 360. What that means is every single angle around is accounted for only one time. So this angle is accounted for with angle 0 degrees, but it is not going to be accounted for with 360. And then if it's, just for example, if it's 15 degrees, then there's only one spot. You're not going to say, let me think, you're not going to say 375 degrees. You're only going to say 15 degrees. Does that make sense what I mean by there's only every point on this circle represents an angle for which the terminal side of the angle intersects the unit circle. So there's only one angle per point on the circle. And this is using the unit circle, so you're going to only have unit circle numbers. If I'm giving you sine or cosine, that means you're going to have either 0 or plus or minus 1 or plus or minus 4, 1 over 2 root 2 over 2 root 3 over 2. Those are the only ones that are going to be given. Root 2 over 2 for a y value, because sine represents y values. Draw a horizontal line that intersects the unit circle at 2 points. So what you're actually finding is the angle whose rotation takes you to this terminal side and the angle whose rotation takes you to this terminal side. And there are two answers. The fact that there are two answers is why I started you yesterday on draw a horizontal line. Now, these are angles that are halfway through quadrants. So what is this angle in quadrant 1 that is halfway through quadrant 1? 45. And I will be giving you unit circles to use starting tomorrow. But first, I want to help you to see how you can use this on your own without a unit circle in front of you. but after today, I will let you use unit circles as we go through these. So 45-degree angle, and then this one is halfway through quadrant 2, so what angle would that be? And you can go ahead and use a calculator. 90 plus 45. And so what angles over this interval solve this equation? And that would be 45 degrees and 135 degrees. And right now, I just want you to find angles between 0 and 360, because this is what's going to later allow you to find any angle you so desire. But first, you want to see the fact that you're getting two separate spots on this circle. Now, who is cosine's reciprocal? Which function is cosine's reciprocal?
Secant.
Yes. And I just realized I can't see my chat. I'm trying to open it, but the internet is extraordinarily slow right now. Anyway, so SEC for secant. And do you remember that with cosine, I told you to draw what kind of lines? Because cosine represents x coordinates. So for a particular x coordinate, you want to draw a vertical line. So let's say, for example, that I ask you for the values of theta. From 0 degrees to 360 degrees, but we're not including 360, only 0. For what values of theta is it true that cosine theta is equal to, let's go with -1/2? Then you want to draw a vertical line. And remember, cosine represents x. You're literally drawing the vertical line x equals -1/2, which is along the x-axis, the first one to the left of the origin. And that runs into two angles between 0 and 360. This angle is 30 degrees beyond 90. So what angle is that one? 120. And then this angle, you can either say it's 30 degrees before 270 or 60 degrees beyond 180. Either or. What angle is that? $240. So what I have here is my answers to theta within this interval are 120 degrees and 240 degrees. And those are two solutions to that equation. Now, who is tangent's reciprocal function? Cotangent. Now, I recommend that if you get either of these two, you want to draw a line through the origin. And I'm going to tell you that tangent and cotangent are the most complicated of all six to go backward on. The traditional way of going backward on tangent is to remember that it is sine over cosine. But whatever number you have that this is equal to, you have to somehow break that up into a fraction, and it isn't just that straightforward. So what I want to do is help you to see that there are only, I just realized I don't have an H on there. I think that's now spelled correctly. Anyway, you listen carefully, and it's going to make tangent much easier to work with backward. I shared a couple things with you yesterday to get started on this, and I'm going to talk you through that before we go any further. Tangent is always slope. If I draw a line through the origin with a 0 slope, that goes through the angles of 0 degrees and 180 degrees. And that is a line that has a slope of 0. The tangent of 0 degrees is 0. The tangent of 180 degrees is 0. So if you are asked, what are the angles where tangent of that angle is 0, as long as it's between 0 and 360, as I was saying before, 0 and 180 degrees would be your answer. What if I asked you, where is tangent undefined? How do you draw an undefined slope through the origin? If you draw a vertical line, the slope of that line is undefined. And so that would be 90 degrees and 270 degrees. Now, if I draw a line with a slope of 1, that means the tangent of these two angles is just flat out 1. What are those two angles? Halfway through quadrant 1 and halfway through quadrant 3 would be 225. If I draw a line through the origin with a slope of -1, actually, I'm going to write that over here. What are those two angles? And what was your last name? That's right. What are those two angles? What's the angle halfway in quadrant 3? Halfway through quadrant 3, right between 90 and 180. What angle is that? How do you know what the slope is? Actually, you know what? I'm showing you this, and then I'm going to do a full-on recap of what I'm doing. And at the end, before I move on to a next step, it will hopefully make more sense. What you do want to realize is when you are at a 45-degree angle, you have a slope of 1. If you are in the heading upward, left to right. But if you're heading downward left to right and you are at a 45-degree angle, your slope is -1. And these angles are 135. And what is this angle? And you've got calculators. So what is 270 plus 45 degrees? 315. So if you are told that your tangent of theta is equal to -1, you can draw a slope of -1 through the origin and realize you are at angles 135 as well as 315. Now, I want you to just stop right here. This is what I talked about yesterday. Of all the angles on the unit circle that you're expected to deal with without a calculator, these are all the angles that you can cope with tangent for if you just understand that drawing a line through the origin with slope 0 means those angles have a tangent value of 0. Drawing a vertical line through the origin, those are the angles where tangent is undefined. Drawing a line with a slope of 1 going halfway through the quadrants, that is a +1 slope. The tangent of these two angles is 1. This has a slope of -1. The tangent of 135 and the tangent of 315 are both equal to -1. Now I want you to see how many angles we have not dealt with yet. Take a good look at how many angles we haven't dealt with yet and realize how much symmetry there is. If I draw a line through the 30-degree angle, it's going to cross over to the other side and also go through the angle 210 degrees. If you are at either of these two angles and you are asked what is the tangent, you're going to get the same number. And you can remember that tangent is sine over cosine. Nose itch. Oh, I hate nose itches in the face mask. So you're looking at your rise over your run. This rise is 1/2. This run is √3/2. if I'm just putting those in a ratio, I could actually look at it as a ratio of a rise of 1 to a rise of root 3, or a run of root 3. So what I want you to see, and really, if you pay attention right now, it's going to save you a lot of grief. This slope is 1 divided by root 3. It is a positive slope. And I want you to, real quick, with your calculator, what is the number 1 divided by root 3?
That's equal to root 3 divided by 3, right?
Yes. And so what was mentioned was the fact that this number also shows up looking different. It is root 3 over 3. Sometimes you'll see it in that format. They're the same exact number. You can get to root 3 over 3 if you multiply the top and the bottom by both root 3. So these are the same numbers representing that slope. Now, what's the decimal number of 1 divided by root 3? Does someone have that? What is the decimal number? 0. Anyone?
57735.
Is that the root 3 over 3?
No, that's 1 divided by root 3.
Or, okay, so that's 1 divided by root 3?
Yeah, that's what you're looking for, right?
Yeah. Hold on one second. Oh, yeah. Oh, I'm sorry. My brain. I just realized why I got confused. You are correct. 0.577. Because for some reason I had it. You know what? I'm not going to tell you what I had in my head. It doesn't matter. Here's what I want you to realize. You know that a 45-degree angle has a slope of 1. Do you see that this is a number that is less than 1? When it comes to steepness of a line is looking at, if you just absolute value the slope, smaller slopes are less steep, larger ones are more steep. When you look at either 1 divided by 3 or root 3 divided by 3, just look at those fractions. Do you see those are fractions who are less than 1? 1 divided by root 3 is bigger than 1. Root 3 divided by 3 is bigger than root 3. These are both fractions that are smaller than 1. On the unit circle, there is only one special angle that is less steep than 1. And that angle happens to be 1 divided by root 3. And I'm going to focus on this version, but they're both the same number. Now, I'm going to move over to if I draw a line through the origin and it is at a 60-degree angle, what is its rise over run? its rise is root 3 over 2. Its run is 1 over 2. Those unit circle numbers we've been looking at. Slope is rise over run. This slope, and I'm just looking at it as a ratio, so it'd be easier to take the ratio root 3 over 1. Which is just plain old root 3. And now I have an important question for you. Is the square root of 3 bigger than 1 or smaller than 1? Just as a number.
Bigger.
And if you have a slope that is bigger than 1, the steepness is steeper than the slope of 1. So really, there are only 2 slope numbers to add to the mix of what I was showing you yesterday. Only 2 numbers. This one has a slope of root 3. And this one has a slope of 1 divided by root 3. That allows me to say that I get an answer of 1 divided by root 3 when my angles are 30 degrees and 180, beyond that, 210 degrees. You're not going to want to memorize all of these numbers. But what I have found really useful is to just remember some basics with slope. And if I have a slope of positive root 3, so if I'm giving you a tangent and the answer is root 3, that's when you're at your 60 degree angle, and 180 after your 60 degree angle, 240. Yeah. So we've got 60, and directly across the unit circle, 240 degrees. Now, here's the good news. There are 2 lines that I haven't drawn in here that are expected for unit circle. They are negative slopes. And they are symmetric to the slopes we just found. What is the slope of this line right here that I just drew? It's a negative slope, and it is less steep than my -1 slope. So it is negative one divided by root 3. Then I have this slope, who is steeper than the -1 slope, but it is a negative slope. And it's steeper than the 1 slope, so it's negative root 3. So that actually finalizes everything we need to know about the unit circle with the tangent values you're expected to work with. And I'll just write those out really quickly. We've got tangent theta equaling -1 over root 3. and tangent theta equaling negative root 3. Negative 1 over root 3, the less steep line, is 30 degrees before 180. And then all you have to do is add 180 to that, because with tangent, they're always directly opposite the unit circle, the pairs of angles for particular values of tangent. And then this angle is 330. So 150 and 330. And then for the negative root 3, the steeper negative slope goes through the angles 90 plus 30 degrees and 270 plus 30 degrees. Now, cotangent is tangent's reciprocal. And I want to be careful about maybe saying too much at once. So here's what I'm going to do. I'm going to erase all this. And I want you to just look at this circle right here. And think about all these lines that I just talked about and what their slope is. So if I say draw a line through the origin with a slope of 0, what would you draw?
I would draw a flat line, but the thing that confuses me is why is basically the tan of 0? Why is that? Why is that a 30-degree angle? Like, why does it do that instead of just if it's 0? Why is it 0?
Wait, where did you see that at?
Like, right, you see where you are right now. Like,
let me make sure this is clear.
Okay, yeah, that makes sense. This is the one to the right of it. You see what I mean?
This one? So that one is 30 degrees.
I just don't know why that is.
Okay. So let me go over this a little bit. Let me start here with, I'll go through them all. If I have a slope of 0 through the origin, that's going to show up at 0 degrees and 180 degrees. If I have a slope of 1 divided by root 3, positive 1 divided by root 3, for me, what I'm looking at is there are only 3 lines with a positive slope that you have to be aware of with the unit circle. One that's halfway through the quadrant with a slope of 1, and then something that is less steep, and something that is more steep. And so this angle for 30 degrees is on a line whose tangent value is 1 over root 3. And if I draw that line with a slope of 1 over root 3, that takes me to 2 places across the unit circle. And you've got 30 degrees and then 180 plus another 30 degrees. And let me tell you, we're going to need to play with this for a while.
All of that made sense.
Uh-huh.
It was the only thing that didn't make sense was when it said 0 theta and its reciprocal function,
Uh-huh.
cotangent,
Mm-hmm.
and it just says line through the origin with a slope of like tan and then theta,
Yeah.
and then it was a 30-degree angle. That part didn't make sense to me. This
Uh-huh.
needs work. There's some
Okay.
on that stuff.
Okay. So with this, I'm actually kind of holding off a little bit on cotangent to first get tangent to make sense. But let me say that once tangent makes sense, for cotangent, whenever I see cotangent show up, I turn it into tangent by reciprocating. And I find that to be, I'm actually going through a lot of stuff with you guys in a few days, in a very short period. This is a lot of stuff. And tomorrow, I need to just review this with you more. So know that I'm not going to step forward into the next classwork tomorrow at all. We're going to need to keep looking at this and understanding it. It's not supposed to be quick, but after a while, you'll be quick at it. Just takes a little bit of time to get there. But I want to kind of hold off on cotangent and focus on tangent for just a little bit. And actually, I think at this point, I'm going to hold on a second. And let's just start off with, let's let tangent and cotangent go for a little bit. And now here we are. If you are given an answer to sine or cosecant, you want to be drawing horizontal lines. And I want to point out that sine represents y. You're actually drawing the line y equals negative root 2 over 2. Along the y-axis, I have negative 1 over 2 and then negative root 2 over 2. So this is the horizontal line that I want to draw. And then what are these two angles? And with finding those angles, you can start at 180 and add 45 degrees. And you've got a calculator. So what is 180 plus 45 degrees? You've got a calculator. $225 degrees. What is this angle over here? $270 plus 45 degrees. So the answers are 225 degrees and 315 degrees. Now, cosecant is the reciprocal of sine. So this is really saying 1 divided by sine theta is equal to negative 2. What does that mean sine theta is equal to? Negative 1 over 2. Do you see that? If I multiply sine theta over here, I divide the negative 2 over to the denominator where that sine theta was. I can also do this. If cosecant is equal to negative 2, negative 2 divided by 1 is another way of writing negative 2. Sine is the reciprocal. So if I reciprocate the function, I reciprocate the fraction. So now I'm going to draw a horizontal line where my sine is equal to negative 1/2. And that would be down the negative y-axis, the first one down. What are those angles? I've got 180 plus 30 degrees and 360 minus 30 degrees. And so my answers are these two. All right, I know you're getting a bit mind tired. And let's see, what time are we at? We've got 10 minutes left. So let me first of all tell you what I plan to do. We're going to go over these two problems, 3 and 4. Your classwork will not be due today. I will change the due date on that. Your homework will not be due today. I will change the due date on that also. And we're going to then come back and tomorrow start in with tangent because it really takes some time for those to soak in. So what I want to do is solidify a bit more how to work with sine and cosine and their reciprocals. So take a kind of stretch. You can do the math dance. The math dance. What's the math dance? Y equals x. Y equals negative x. Y equals x squared. Y equals negative x squared. Y equals x cubed. Y equals negative x cubed. We can keep going. Y equals absolute value of x. Y equals negative absolute value of x. Good exercise. That's called mathercise. All right. So you need to move around. All of you online, move a little bit. Stand up, stretch. If you're here in class, stand up and stretch. You need to just a little bit. No one ever wants to stretch in the classroom. We're always too concerned about how people see us, aren't we? Oh, I'm sorry. I didn't mention the people who did. Some of you stretched. Okay. Now, let's refocus. Does cosine represent x or does it represent y? When you have an xy ordered pair, x comes before y in the alphabet. C comes before S in the alphabet. X represents cosine. If you draw the vertical line x equals negative 1/2 along the x-axis, that is on the negative side of the x-axis, the first one away from the origin, draw that as a vertical line, and that intersects the unit circle at 2 angles. And I want to make sure that you understand what we just did with that. I'm going to draw this terminal side and this initial side. If an angle turns this much, it has a cosine value of -1/2. Uh-huh. We are doing a quiz today. Oh. So I need to release the quiz and maybe just get back to this later. So I'm going to stop the recording.